So, good afternoon, students. Yesterday, we have discussed about the random variable, and day before, not yesterday, day before yesterday, we have studied about the random variable. And if I just rejoice that what we have studied is that we have studied the definition of random variable, and I told you that how to use random variables. Okay. Then we have discussed that the existence of this random variable depends upon the chance. Then we discussed two types of random variables. That is, one is the discrete, and then one is the continuous. Then in that, I have discussed about the probability distribution. That is how, as per the random variables, the probability of a function associated with each random variable can be calculated. And what are the properties of this probability distribution? That is, they all should be greater than 0, negative numbers, and should sum up to 1. Okay, this we have discussed. Then we have discussed about the discrete probability distribution. Data, the random variables are discrete in nature, and hence the probability associated with it is also discrete. Then we have discussed certain examples. Then we discussed about the continuous probabilities, and there we cannot just show up this continuous probability distribution in the form of a table that we have discussed. Okay, but one has to look for the interval instead of a particular value in case of continuous probability. Okay, so I have stopped here. That is a statistic of random variable. Till now, I have an idea that you have already been covered with measures of dispersion and measures of central tendency. And in particular, two of the measures out of that we will be discussing here. One is your mean, and one is your variance. So basically, what we are going to study here is, where we have studied that how to calculate the mean of a group and ungrouped data. Similarly, we have studied that how to calculate the variance of a group or an ungrouped data. Okay, and that when it is a group data, then we make use of frequency. Okay, and when we talk about this probability, so, in probability, one of the definition we have studied is that we can calculate the probability from the relative frequency. Okay, and when we know the relative frequency of occurrence of the each random variable, then the probability associated with that variable can easily be calculated. So, today we will be learning out of that probability. Once we are knowing now that we have a random variable, we have the frequency of occurrence, so accordingly we can calculate the probability. What next? So what I mean to explain here is that we can calculate exactly the mean from probabilities also, as we have calculated the mean from the frequencies. So we can also calculate the probabilities from a not probability, the mean using the probabilities associated with the random. So what is that mean of a random variable? The mean of a random variable, also known as its mathematical expectation or simply expectation. Just concentrate on this word, expectation or expected value. Okay, it is also known as expected value, is defined as the sum of the products of the values of the random variable and the corresponding probabilities. Okay, what it is equal to? It is equal to the sum of the products of the values of the random variable and the corresponding probability. Okay, so if you are having any difficulty anywhere in this lecture, okay, So you can send me the message on the live chat box from the YouTube itself. Okay, as I am sending you all the good afternoon. Okay, so that I will come to know about any difficulties you are facing in the lecture. Okay. So what this which I have highlighted, the sum of the product of the values of random variable and the corresponding probabilities. What does it means in mathematical notations? The mean of x or the expectation of x is equal to the, if this is the first random variable, multiply the probability of the first random variable with its value, and if it is the second random variable value, multiply its corresponding probability with it, and so on. And summation of this, that is adding all these, will constitute the mean of the data. Okay. So let us now see that you have a. We are now explaining one of the example here. Okay. So now let us take the data of in example 3 to discuss the above formula. Okay. So I will just take you back to the data of not example 3 actually. Yeah, it is this example. Okay. So this is the liter size, and these are the number of boards, relative frequency of number of boards having one kid or two kid, and these 10 boards are having three kids and five boards were having four kids. Okay. So this we were having, and we have calculated the probability of occurrence here, that is 0.6, 0.25, 0.1 and 0.05. So it sums out to be 1. Okay. So in that, now we will be calculating the mean of this data. Okay. So we have already calculated up to this. Okay. And I will just try to compare this with your earlier formula. But if it is the case of when you were we were calculating the mean in the first chapter, that is measures of central tendency, what we will do, we will multiply this 60 with this value, isn't it? That is fx. So this 60 into 1 is 60, 25 into 2 is 50, 10 into 3 is 30, and 20 into 4 is, oh sorry, 5 into 4 is 20. Okay. And what this formula says, you have to multiply the value of this x with the corresponding probability. So this 0.6 into 1 is 0.6, then this 0.25 into 2 is 0.5, then 0.1 into 3 is 0.3, then 0.05 into 4 is 0.2. And if you sum these up, so it will come out to be 1.6, which is your expectation. Okay, that is, we have studied that sigma is p x into x is equal to the your mean. Okay, and it is denoted by ex, expectation of x. Okay. Okay. So now we will just compare this with our earlier formula also. This sigma fx is 160 and this sigma f is 100. So if we divide this sigma fx1 fx with sigma f, we will again get 1.6, and same is the answer we are getting with the program. So this is what this has said, that if you want to calculate the mean of a random variable, simply multiply the probabilities associated with each random variable, sum them up, so you will get the mean of that data. Okay. So this is what we were discussing. So, but for a continuous random variable, if the random variable is continuous in nature, so that sigma, okay, because it has been used in discrete, so that sigma will be replaced by the integration over an interval from a to b of px into dx. Okay. So the expectation of a continuous random variable can be calculated using the integral, definite integral. Okay. Here x is a continuous random variable with domain from a to b, and px is its probability. Okay. So now we will just try to understand this thing with some of the examples. Okay. So why it becomes important to us. So this example particularly states that a cow gives 6 liter extra milk when given ration A, 3 liter extra milk when given ration B, and 3 liter less milk when given ration C. So a cow has been given three types of rations. Okay, and what has been observed is that one ration A is given, so it was giving plus 6 liters of milk. Okay, if ration B is given, then it is giving plus 3 liter of milk. And if ration C is given, then it is giving minus 3 liters of from the base value. Whatever the base it may be 10 liters on an average it was giving. So by introducing these rations, it was either giving more or less. So what they are asking is that what will be the expected extra or less milk obtained if the cow is given rations randomly. So on a day you choose the ration randomly. Okay, out of three you just take one slip. Okay, and repeat this experiment over the period. That is, say for example, 100 days or 200 days or over the year. Okay, or for the lactation throughout the lactation. So what you will observe that frequency, whatever answer we will be getting here, that you will get there also. As I have showed you in the one of the figure also, that when the number of throws of a tossing of coin increases, so the probability of getting either tail or head like that normalized to its actual value. Okay, so you might not get these results in 1 or 2 days, but as the number of days will increase, so you will get this. Okay, so now let us do that. How to do this? So we were having three rations. Okay, ration A, ration B, and ration C. What are the chances that a ration on a particular day, ration A will be selected? So it will be 1 out of 3, isn't it? That is, the probability of selecting A will be equal to 1 by 3. And similar is the case with the probability of selecting B ration, isn't it? And probability of selecting the C ration is also equal to 1 by 3. So, and if you will just sum them up, so it is a case of probability distribution, exhaustive events. So these all sums to be 1. Okay. Now extra milk we are getting is plus 6, plus 3 and minus 3. Now we will be multiplying as per the formula this probability associated with each random variable. Okay. So this 6 into 1 by 3 is 2, 3 into 1 by 3 is 1, and minus 3 into 1 by 3 is minus 3. And then sum them up. So it will come out to be 2 liter. So what you will observe, if you will give these rations randomly, that is sometimes A, sometimes B, sometimes C. So you are going to get this EX expected 2 liters more milk on an average. Okay, so this is how this the expectation or this mean. Okay, that is here instead of frequency, you will be having the probabilities associated with the random. Okay, so if you are having any difficulty, you can ask me in the chat box. So I will answer accordingly. Now we will be learning about the properties of mathematical expectation or mean. Okay. So the mathematical expectation of a constant is the constant itself. That is, if we take the mean of a constant, that is, say for example, I am having 7, 7, 7, 7, 7 like this. Okay, and you take the mean, so it will come out to be 7, isn't it? So similar is the case here. So expectation of a constant is equal to the constant itself. Okay, this is the first property. If you multiply the value of a random variable with a constant, so it will be equal to, that is, first you multiply the constant with the random variable and take the expectation. So it will be equal to the constant multiplied with the expectation of x's. Okay. So this is the second thing. Third thing is, this is the formula what we have seen. This has been stated away. And for continuous variable, we have to go for the integration instead of that summation. Okay. Then another important property of mathematical expectation is that if there are two variables, random variables, that is x and y, and you sum them and calculate their expectation or mean value. So it will be equal to the mean of the first random variable plus mean of the second random variable, provided they are not dependent on each other. That is, they are independent. Okay. Similarly, the mathematical expectation of product of a given number of independent random variable is the product of their expectations. That is, if we are having two random variables and we multiply them and take their mean, it will be equal to the mean of the first random variable into the mean of the second random variable. Okay. So these are some of the properties of the expectation or the mean that has been calculated from the probability. Okay. Now we will be learning a little bit about the variance of a random variable. Okay. That is what variance. So in chapter of measures of dispersion, you might have already learned about the variance. Okay. Now we will be learning that how to calculate a variance from the probabilities associated with the random variable. Okay, as we have studied that we can calculate the mean using the probabilities associated with a random variable. Similarly, the variance can also be calculated from the probability data, okay, or the probability distribution, right? So here in the same example, now let us take the data in example 6 to discuss this formula. What is that formula? That the variance of a random variable is equal to the expectation of x minus expectation of x, okay, and its whole square, okay, and this is equivalent to expectation of x square minus expectation of x whole square. Okay, so now let us just find out that whether this is exactly holds true or not, and also check it with our previous knowledge of our variance calculation. Okay, so now we were having these values, that is 1 2 3 4 kids, and we were having the relative frequency of votes, those are giving births, and accordingly we were having this probabilities. Okay, now first of all, we have already calculated this EX in our previous example, and that EX has came out to be 1.6. Okay. Now, if we calculate this X minus EX, that will be equivalent to, as you are deducting the mean from the value. So here this x is 1 and you have to deduct this yes, 1.6. So when you will be deducting 1.6 from 1, so 1 minus 1.6, 1 minus 1.6, we will be getting minus 0.6. Okay, this one. Okay, when you will be deducting this 2 minus 1.6, so you will be getting 0.4. When you will be deducting from 3, you will be getting 1.4, and when you will be deducting from 4, you will be getting 2.4. Okay, now let us make a square of this. Okay, when we will be squaring it, it will become 0.36 from 0.6 into 0.6. This will become 0.16. This will become 1.96, and this 2.4 into 2.4 is 5.76. Okay, now this constitutes your this part, this whole square. Okay, x minus ex. If we start from here, so it is x minus ex whole square. And if we sum these all, it will be the expectation of x minus ex whole square, isn't it? So yes, but first, if this is the variable, then we have to multiply this with the for expectation we have to multiply this with the probability, isn't it? So when we will be multiplying this 0.36 with 0.6, we will be getting 0.216. Then we have to multiply this 0.16 with this 0.025. So we will be getting these values, okay, isn't it? This value into px. So we will be getting these values, and the expectation of this value will be the summation of these. So when we will be adding, so it will come out to be 0.7, which is your variance. So your variance will come out to be 0.7. Okay, you can do it using the formula and from your previous, that is sigma f into xi minus x bar whole square divided by sigma f. You will again get the same answer. Okay, so you can do that with yourself. Okay, now the other part, that is ex square minus ex whole square. Okay, so now this thing I have calculated here, this x minus x bar into whole square. Okay, so this will be 21.6. That is, you have to multiply this 60 with the probability, that is 0.6. So this will be here, these values, and it will sum out to be 74. And when this 74 is divided by 100, so it will be 0.74. So either you go with the trivial formula or go with this formula of probability function, you will get the same variance. Okay, now similar thing I will try to make you understand using the expectation of x square. This is what? This is expectation of x square. So first we have to calculate the x square, and then we have to multiply that with the probability, associated probability. So what is x square? These are the values of x. So 1, this will be 2 to the 4, 3 3s are 9, and 4 4s are 16. And then multiply with the px, that is the 0.6, 0.25. So you will get these values. And when you will be getting these values, you sum them up, it comes out to be 3. So now let us see that what the third formula will give us, that is expectation of x square minus expectation of x whole square. So this 3.3 minus this we have already calculated, expectation of x was 1.6, 1.6 whole square is 2.56. So 3.3 minus 2.56, we got the 0.7. So hence the variance of this probability distribution is 0.7. So by using these two formulas, if you have been given some probability distribution, you can very well easily calculate the mean as well as the variance of that distribution. Okay, so as we were having some of the properties of the mean, we are also having the properties of variance. Okay, so variance of any constant value is equal to 0, and I have already told expectation of a constant is constant. Okay, then variance of the product of this, that is, if you do multiplication of a constant with your random variable, it will be equal to c square into vx. Whereas in case of this expectation, earlier we have studied, this is equal to c into expectation of x, isn't it? Then if we have two random variables and we calculate the sum of these two, so it will be equal to variance of x plus variance of y plus choice of covariance of x and okay. So if they are dependent, and if they are independent, then this part will become 0. So it will only be equal to variance of x plus variance of y. Okay, and where this covariance of xy can be calculated using the probability functions like this, that is, this formula has been given, expectation of this x minus ex or y minus ey, or this expectation of xy minus expectation of x into expectation of y. So we are not going too much in details in the practical exam about these driving these values using the probability function. My idea to give a little bit in theory is um, Tyagi is asking that 3.1.1. Okay, third point. Actually, why I have skipped this point is that in the beginning, when I have started, Yash, about this probability function, I have given this formula, and this same formula has been explained in case of third point. So what is has been given here is the mathematical expectation of any function of a random variable is the sum of the product of the values of the function and the corresponding probabilities. Okay, this is what the formula is. So it is just a mere repetition. Okay, of the values of the random variable. Thus, if fx is a function of a random variable x, takes the values x1, x2, x3 with specific probabilities p1, p2, p3. So you can simply calculate this by multiplying the value with the corresponding probabilities. Okay, this is what we have studied in your this part. That is when we have started. So that is why I just skipped. Same thing has been explained as a properties. Okay. So I think now it is clear. And if it is a continuous variable, then it has we have to take the integration instead of this sum. Right? So I think now it might be clear to you. So what I was telling here is that these numericals we are not going to ask for these things, but our idea to tell you about this mean and variance in this probability distribution is that if instead of a frequency you have been given a probability distribution, okay, and you have been asked about the mean and the variance of that probability distribution, you can calculate using these formulas. Just for your knowledge, okay, we have explained this. So now we will move on to our next thing, and that is a very important thing, and you will find lot of application of this in statistics. So that is standard normal variate. So for any variable, let it be random or otherwise, okay, with a given mean and a standard deviation, you have a random variable, okay, and for that you know that what is the mean and the standard deviation, okay. So you do one thing that when the mean is subtracted from it and the result is divided by the standard deviation, okay, the mean is subtracted from the value, okay, and the random this and the result is divided by the standard deviation. The resultant variable has mean equal to 0. Okay, whatever the resultant variable you will be getting, so that will be having the mean equal to 0 and a standard deviation equal to 1. Okay, and a standard deviation equal to 1. So what you do, you have say for example some values, okay, and in those values you subtract the mean from it and then divide it by the standard deviation and then sum them up. So what you will find that that variable you will be having mean equal to 0 and the standard deviation equal to 1. Okay. So say for example Z is a standard normal variate obtained from a data that is having mean and a standard deviation. From that data we subtracted the mean, okay, and then divide it by the standard deviation. So if we sum that Z scores, so its sum will be equal to 0. And if we take the variance of that Z score, so that will be equal to 1. Okay. So the variable Z is defined in the above manner is called standard normal variable. So what this Z variable is known as standard normal variable. Okay. So later on we will consider how this result is used in context of normal that we are going to study. Okay. So now we will take up your first probability distribution. Now we are through with random variables. We are through with the probability distribution. We are through with certain statistics associated with the random variable and the probability distribution. That is the mean and the variance. And now we have some idea about the standard normal variant also. That is, a standard normal variant have a mean equal to 0 and the standard deviation equal to 1. Now we will be studying our first probability distribution, that is binomial distribution. So the binomial distribution is an example of discrete probability distribution. We have already studied this thing. What is a discrete probability distribution? Then James Bernoulli, okay, he was the scientist, James Bernoulli, presented it in the year 1700, and the word binomial suggests two. Okay, what does this binomial means? Two. It signifies two possible outcomes of an experiment: the occurrence of an event or non-occurrence of the event. Either an event will happen or an event will not happen. So a probability experiment that can be termed as a Bernoulli experiment if it satisfies the following conditions. And what are those conditions? The experiment consists of a sequence of n repeated trials. That is, it should have some repeated trials. Okay. Then each trial result in an outcome that may be classified as a success or a failure. That is, either you get what you want or you don't get what you want. Okay. Then the probability of a success is denoted by P, is known that is, you know that what is the this probability of success. Okay, and it denoted by P and remains the same in each trial. For every trial, that probability should remain same. Okay, and consequently the probability of failure, which is denoted by Q, is equal to 1 minus P. We have already understood this thing from our probability chapter, is also known and remains the same in each trial. Okay, so the probability mass function of such a trial or this binomial distribution is given by the formula. This Px is equal to, this is the combination sign we have already discussed in your earlier this probability chapter, that is NCX P power x Q power n minus. Okay, so as for now you should learn this formula, and now we will be seeing that how to apply this. There are two more things about the binomial distribution. And what are those things? That the mean and variance of a data obeying binomial distribution is given by the expression Ex is equal to NP and variance is given by the NPQ. Okay. So now let us take an example from our first example. Okay. So and apply that example to the binomial distribution. Okay. So a candidate doesn't know answer of two multiple choice questions out of 100 MCQs in a paper. So he decided to go by his luck and started picking randomly. So what is the probability distribution for his chances of picking the right answer? Okay. So now the random variable here will be the sample space of number of answers attempted correctly in the chance experiment. So what are those? In first also we have, first example we have studied that either none of the question will be correct, or one of the question will be correct, or both of the questions will be correct for that student. So now if W, this W presents your ticking wrong option, and R represents your picking right option. The pivot table for various combinations will be okay. So there will be 4 options for each question, and this say for example this denotes your first question, the upper row, and this column denotes your second question. So let us consider that one of them is correct option, that is the right option, and others are the wrong option. So the candidate will either be doing both questions correct, first cell, first question correct, second question wrong, first question right, second question wrong, first question right, second question wrong. Okay. Similarly here is right wrong, and in these cases both the questions will be wrong. Okay. So out of this 1 2 3 4 and 1 2 3 4, that is 16 chances of picking in different ways those options, because every question will be having four options. Okay. So out of those only one case is there when he will be picking the right answer for both the questions. Okay. And there will be 1 2 3 4 5 6 chances of correcting one question correct, and there are 9 events where we will be picking both the questions incorrect. Okay. So now it is clear from the pivot table that the total number of possible ways of picking the options will be 60 for these two questions. And P is the probability of success. What is that probability of success? Is 1 by 4. That is, out of the total, you can be succeeded in 1 by 4 share. Therefore, Q is the probability of failure, which will be equal to 1 minus P, that is 1 minus 1 by 4. So it will be 3 by 4. So the probability distribution will be given by, how it will be given by, our random variable is 0, 1 and 2. And from our pivot table, we have taken is none of the question correct, 9 by 16, one question correct, 6 by 16, and two questions correct, 1 by 16. Now this thing, because here it has met all the preconditions of a binomial distribution. Okay. Because every time in each time when he is either doing first question or second question, probability of picking remains the same, that is 1 by 4 and 3 by 4. Okay. And similarly, it is repeated two times. It has been repeated to certain extent. Okay. So it has to follow the binomial distribution, which is given by this formula. Okay. So as we have calculated the probability, although using this pivot table, okay, but we can also do this using the binomial distribution equation. And why this equation becomes important? Because here I am asking about two questions only. I may ask about 3 questions, 10 questions. Instead of 4 options, there might be 6 options, 7 options. So your probability of picking the correct answer also decreases by that way also. So in that condition, you will be requiring this probability as per the binomial distribution equation. Okay. So when you will be applying this binomial distribution, we have already learned in our previous probability chapter. So it will be 2C0, this P power 0 and Q power 2 minus X from here, this form. Okay. So when we will be applying, this will be equal to 1. This value will also, anything power 0 is 1. Then this will be 3 3s are 9 and 4 4s are 16. 9 by 16. So it all comes out to be 9 by 16, which is equivalent to what we have calculated from our pivot table. Okay. Similarly, if we see this thing, okay, so here this 2C1 will be equal to 2. This 1 by 4 power 1 will be 1 by 4. And this 3 by 4, 2 minus 1 remains 3 by 4. So it will comes out to be 6 by 16, which has been obtained from the pivot table as well. Okay. Similarly, in this case, probability of selecting both correct answers, 2C2, this is 1 by 4 power 2 and this 3 by 4 power 0. So it will be 1 into 1 by 16 into 1. So it will again come to be 1 by 16. So either you go by the pivot table or you apply the binomial distribution, you are getting similar type of distribution here. And when you will be adding these up, okay, so it will be equivalent to, okay. So this is how the probability mass function of this random variable obeys the binomial, right? Now again, we are calculating one more example. Let us find out. So the chances of getting an elite bull, how we can apply this in case of our farms, that is the chances of getting an elite bull from a calving on a farm are 1 by 20. If there is a calving, there are chances of getting an elite bull is 1 by 20 every day. Okay, so if there are 120 calvings, what will be the expected number of lead bulls and what will be the variance? Okay, and from here how to do that now, because it is here n is 1 by 20, 120, then p is 1 by 20, so q will be 19 by 20. So the expectation of a binomial distribution from the formula we know it is equal to NP. So it will be equal to 120 into 1 by 20 is equal to 6. So out of this 120 you will be getting 6 liters. Okay. Then what will be your variance? Variance will be equal to NPQ. So 120 1 by 20 into 19 by 20, so it will be 5.7. The variance of getting an elite will be 5.7, and the mean of getting average out of 120. This is how we can apply these formulas to calculate various. Okay. Now, graphical presentation of a binomial distribution. In many of the textbook, I haven't seen any graph for this binomial distribution. Whenever you go for any textbook, you will always get a graph for this normal distribution, which we will be studying later on. Okay, but you will never get a graphical presentation of binomial distribution. What I want to tell you why I have put it here is that when the number of this data increases, number of these values, so this binomial distribution approaches normal distribution. So binomial distribution is also having a bell-shaped curve graph. Okay, so this is just to show you that in case of binomial distribution also we got this bell-shaped curve. Okay, so binomial distribution can be plotted graphically using probability curve with the number of events on x-axis and the probability function on the y-axis, as we have here now. This so this number variable 0 1 2 on this you can have on the x-axis, and this probability, whatever probability you are getting, you can plot it on the y-axis. Okay, so when you will be doing this thing, so this is the graph I have got for one example we will be discussing and then leaving it for the next class. So if there are 8 calvings in a farmer's cattle herd, draw a binomial distribution of getting a male calf. So here also what you will see that getting a male calf, the probability remains same every time. Okay. And probability of getting a female is also half, and the probability of getting a male is half. And here we are waiting for 8 calvings. Okay. So out of these 8 calvings, how many random variables can there? Either we will get no male calf, one male calf, two male calves, female calves, four male calves, five, six, seven, or all the male calves. Okay, and these are the probabilities associated with these numbers. That is, probability of getting none of them, all of them female will be 0.004. Okay, probability of getting one of them male is 0.031. Then probability of getting the two of them male is 0.019. So what I have done here is that this total is 8, and out of that 0, then 1 by 2 power 0, 1 by 2 power 8 minus 0. So similarly I have calculated here. So these are the values for the 8 columns. Okay, and when we plot this probability on the y-axis and number of carvings on the x-axis, so what you will see that the maximum probabilities is of getting half of the males and half of the females. Okay, and this follows a standard pattern of bell-shaped curve. Okay, although the data on the x-axis is not continuous, it is instead discrete. Okay, then similarly there is one question to make you understand about this probability distribution. I will leave here. So, in an organized cattle farm, about 20% animals were yielding average milk less than 5 liter per day. If a person select 5 animals randomly at that farm, what is the probability of getting less than 3 animals yielding average milk less than 5 liter per day? Okay, so because here what you will see that the n is 5, t is 20% is 0.2. Okay, and then what is your this p is 0.2, so q will be 0.8. Okay, 0.8. So the random variable, either this random variable, either there will be 0 animal, 1 animal, or 2 animal, because we are going to have the getting probability of getting less than 3 animals yielding average milk less than 5 liter, which is the condition. So when we will be putting these values in this, so you will get these probabilities. This is equal to, and you sum them up, so it comes out to be 0.5. Hence, there are 50% chances of getting less than 3 animals out of 5 selected animals yielding average milk less than 5 liters a day. So this is how, by applying your binomial distribution to the certain conditions where there are chances of success or failure, the events can be classified on the basis of chances of success or failure. So you can calculate the probabilities, you can calculate the mean, you can calculate the variance, and you can forecast also, and you can see the insights of that data, that what will be the probabilities at this level. Okay, so this is all for today's class. Thank you very much for your patience hearing. So I can see that there are no more questions. So we will be taking up the Poisson distribution, that is your next distribution tomorrow morning class, and continuous. This is also a discrete probability distribution. So this is all from my side. Thank you. Thank you very much.